Hello, hi everyone. Welcome to this online video classes. This is Dr. U. Raghavinder, Assistant Professor of Chemistry, MVS Government Degree and PG College, Mahabub Nagar, Telangana. In this video, today I want to discuss about cyanides and isocyanides. Okay, fine. Next, in this video, I want to go to discuss about the following contents, that is introduction of cyanides and isocyanides, nomenclature, preparation methods of cyanides by using alkyl halides, amides, aldoxymes, and also preparation methods of isocyanides by using alkyl halides, amines, N-alkyl formamides. Next, about physical properties of cyanides and isocyanides, as well as chemical properties of cyanides and isocyanides. In chemical property, I would like to discuss about some chemical reactions, that is hydrolysis, addition of Grignard reagent, reduction reaction, and also about oxidation of isocyanates. Okay, fine. Next, first one is introduction. Here, cyanides and isocyanates, generally both are, they belongs to a family of nitrogen compounds. In organic compounds, there are some nitrogen compounds. The compounds which have carbon, hydrogen and nitrogen atoms, generally considered as nitrogen compounds. Here the cyanides and isocyanates also belongs to the family of nitrogen compounds. We have that specifically the cyanides, specifically cyanides and isocyanates, both are derivatives of, that is alkyl or aryl derivatives of hydrogen cyanide and hydrogen isocyanide respectively. That is, here the cyanides and isocyanates are generally, specifically, they are alkyl or aryl derivatives of hydrogen cyanide and hydrogen isocyanide respectively. That is, alkyl cyanide or aryl cyanides are derivatives of hydrogen cyanide and alkyl or aryl isocyanades are the derivatives of hydrogen isocyanide. Okay. Here hydrogen cyanide and hydrogen isocyanide both are tautomers to each other because they shows a difference in the attachment of the hydrogen atom only. They are 1 3, they are 1 2 hydrogen tautomer, 1 comma 2 positional tautomers. That is, here the attachment of the hydrogen changes from one position to two position. That is, they are 1 comma 2 tautomers, positional tautomers. So here the derivatives, that is derivatives of hydrogen cyanide and hydrogen isocyanide, that is cyanides and isocyanates, both are, they are functional group isomers each other. In the case of cyanides, they have a functional group cyanide group. In the case of isocyanates, they have a functional group isocyanate functional group NC. The general formula of cyanides is RCN, while the general formula of isocyanate is, it is RNC. Sorry, it is RNC, not RC, it is RNC. The general formula of isocyanates is RNC, it is not R, mistake, sorry. Okay, here the both, that is cyanides and isocyanates, both are functional group isomers. They have same chemical formula, but they shows difference in functional group only, so they are functional group isomers. In the case of cyanide, the functional group is cyano group CN, but in the case of isocyanates, it is NC, isocyano group. NC is functional group. Here the both the molecules, that is cyanides and isocyanides, if you observe the structure of the cyanide and isocyanide, they are linear molecules. Both cyanide and isocyanides are linear molecules, and also they have a triple bond in their functional group. Cyanide is or CN, sorry, or CN, the triple bond. It is or CN, or CN, or single bond CN. But in the case of isocyanate, it is or single bond N, double bond C, and there is a covalent coordinate bond from nitrogen to carbon. It is also triple bond. Here both cyanides and isocyanides both are linear molecules with a triple bond in their functional group. There is a triple bond in between the carbon and nitrogen in both the cases. Here it is hydrogen cyanide HCN. If you replace the H with alkyl or aryl, it may be or equal to or is equal to aliphatic, or it may be aromatic, whatever it may be. By removing H and adding or, we get RCN, it is alkyl cyanide. If R is equal to aryl group, it is aryl cyanide. Here HNC, it is hydrogen isocyanide. Here generally there is a triple bond. It contains one sigma bond, one pi bond, one covalent coordinate bond from nitrogen to carbon atom. If you replace H with R, then we get corresponding isocyanide, alkyl isocyanide. If R is aryl group, then it is aryl isocyanide. Okay, fine. This is about the introduction of cyanides and isocyanides. Next, nomenclature of the cyanides and isocyanides. If you observe the nomenclature of cyanides, generally there are two methods in order to name a given particular organic compound. The first one is common system. The second one is IUPAC system. In the case of cyanides, according to common system, cyanides are generally named as alkyl or aryl cyanides. Alkyl or aryl cyanides by adding a suffix cyanide to the name of alkyl or aryl radical or group. That is, in order to name a given cyanide molecule according to common system, we have to add cyanide suffix to the name of that particular aryl or alkyl group. Then we get the name of that particular compound as alkyl cyanide or aryl cyanide. Okay, this is according to common system. If you observe the example, it is first one is CH3CN. It is according to common system, the name of CH3CN is, it is methyl cyanide. It is CH3 is alkyl radical of methane, so it is methyl cyanide. Here next one is C6H5CN. It is known as phenyl cyanide. According to IUPAC system, second one is IUPAC, International Union for Pure and Applied Chemistry. It is the internationally adopted system. According to this system, each compound or each molecule gets a specific name according to some priority rules. In the case of cyanides also, each cyanide molecule get a specific name according to IUPAC system. According to IUPAC system, generally the cyanides named as alkane nitriles. They named as alkane nitriles. Named as alkane nitriles or arene nitriles in the case of aromatic cyanides. That is, according to, in order to name a particular cyanide compound according to IUPAC nomenclature, we have to add nitrile suffix to the name of the parent hydrocarbon. Then we get IUPAC name of that particular cyanide. Okay, if you observe the example, the first one is CH3CN. It is generally derivative of ethane. That is, we have to give numbers according to priority rules. So we have to give first number to the carbon of the cyano group. So we have to also count the carbon of the cyano functional group. So it is first and second contain two carbon. So two carbon containing alkane is ethane. So ethene, name of this particular cyanide is ethane nitrile. Here it is aromatic cyanide. In the case of aromatic cyanide, we have to name benzo suffix to the arene followed by nitrile suffix. In the case of this compound, that is C6H5CN, it is benzonitrile. It is cyanide compound of benzene. So instead of writing benzene, you have to write benzo and followed by the suffix nitrile. It is benzonitrile. Naphthalene, if the naphthalene compound contains cyanide group, then it is naphthonitrile based on the position of the nitrile group or cyanide group. So according to IUPAC nomenclature, they simply considered as alkane nitriles or arene nitriles. In the case of arenes, we have to add O suffix to that particular arene. Remove NENE from the arene name, aronitrile. That is, simply in the case of aromatic cyanides, it is aronitriles. In the case of aliphatic, it is alkane nitriles. Okay, fine. If you observe the nomenclature of isocyanides, in the case of isocyanides, there is no specific IUPAC names for isocyanides. Simply isocyanides molecule named according to common system. According to common systems, isocyanide generally named as alkyl or aryl isocyanides or alkyl or aryl carbyl amines. By adding isocyanide or carbylamine suffix to the name of that particular alkyl or aryl group. In the case of aliphatic isocyanides, it is alkyl isocyanide or alkyl carbylamine. In the case of aromatic compounds, it is aryl isocyanide or aryl carbylamine. This is naming of isocyanide compounds according to common system. There is no particular IUPAC names for isocyanide compounds. Simply they considered as alkyl isocyanides or alkyl carbylamines. Sometimes they also considered as isonitriles. In the case of cyanides, they are nitriles. Here the isocyanides also known as carbylamines or isonitriles. If you take example CH3NC, CH3NC, it is methyl isocyanide or methyl carbylamine. In the case of C6H5NC, aromatic isocyanide, the name of this compound is phenyl isocyanide or phenyl carbylamine. Okay, fine. Next preparation methods of cyanides. Preparation methods of cyanides. and isocyanides. The first one is preparation methods of cyanides. First preparation method is from alkyl halides. Preparation of cyanides from alkyl halides. Alkyl halides on treatment with alkali cyanide, that is maybe potassium cyanide or sodium cyanide, produces corresponding alkyl cyanides. That is treatment of alkyl halide with alkali cyanide, then we get corresponding cyanides, alkyl cyanide derivatives. This is preparation of cyanides from alkyl halide. In this method we also get small amount of isocyanates also, but the major product is cyanide. That is reaction of alkyl halide with alkali cyanide, we get alkyl cyanides as a major product, and also alkyl isocyanide with small amounts. That is the major one is alkyl cyanide. If you observe the reaction, alkyl halide reaction with potassium cyanide, then we get corresponding alkyl cyanide or CN. If you take example, specific example, C2H5Br, that is ethyl bromide reaction with potassium cyanide, we get ethyl cyanide. Here if you observe the reaction, generally the reaction is example for nucleophilic substitution reaction. Here the alkali cyanide, whether it may be potassium cyanide or it may be sodium cyanide, generally it is an anionic compound, so it liberates easily cyanide nucleophile Cn minus, liberates Cn minus, generally negative charge present on carbon. This cyanide nucleophile undergo nucleophilic attack on alkyl halide, then the X replaced by cyanide nucleophile, then we get corresponding alkyl cyanide molecule. So generally it follows nucleophilic substitution reaction mechanism based on the alkyl halide. If the alkyl halide is primary alkyl halide, it generally follows SN1 type mechanism. If it is secondary, it may undergo according to SN1, or it may, sorry, in the case of primary alkyl halide, it undergo according to SN2 mechanism. If it is secondary halide, it may undergo through SN2, or sometimes it may be SN1 mechanism based on the conditions. In the case of tertiary halides, if you take tertiary halide in this reaction, then the reaction follows SN1 type mechanism, that is unimolecular reaction. But primary halide and secondary halides majorly follows SN2 mechanism. Okay, next, preparation of cyanides from amides. Next one is preparation from amides. Amides are generally, they are derivatives of carboxylic acids. There are 4 derivatives of carboxylic acid. They are esters, anhydrides, acid halides, amides. By treating carboxylic acid with ammonia or ammonia derivative, that is amine, we get corresponding amides. That is the generation of amides from carboxylic acids. If you treat the amide molecule with a dehydrating agent such as phosphorus pentoxide or acetic anhydride, then we get corresponding alkyl cyanide. Here dehydrating agent means it absorbs water molecule from the substrate or reactant molecule, or removes water molecule from the substrate. That is the nature of the dehydrating agent. Majorly phosphorus pentoxide, acetic anhydride generally used as dehydrating agent for this purpose. Okay, I will show the reaction in the next slide. Okay, if you observe the reaction, preparation methods of isocyanates, we can also prepare isocyanates by using alkyl halides, as in the case of cyanides. The case of cyanides, alkyl halides treated with alkali cyanide, potassium cyanide or sodium cyanide. But in the case of preparation of isocyanide, we have to treat alkyl halide with silver cyanide instead of treating with alkali cyanide. If you treat with alkali cyanide, we get cyanide. If you treat alkyl halide with silver cyanide, then we get isocyanide as a major product. In this reaction, we get small amount of cyanide as side product. Why we get isocyanide in the case of treating of alkyl halide with silver cyanide? Why we get cyanides by treating alkyl halide with alkali cyanide? As we discussed here, in the case of cyanides, this the alkali cyanide generally produces freely cyanide nucleophile which contains negative charge on the carbon atom. This cyanide undergo nucleophilic substitution on alkyl halide through carbon nucleophile. Then we get corresponding cyanide. In the case of isocyanide preparation, where we have we are treating alkyl halide with silver cyanide. Here the silver cyanide generally it is not a completely ionic molecule. There is no it don't liberate free cyanide nucleophiles. Generally it is a covalent compound. Silver cyanide is a covalent type compound, so there is no availability of free cyanide nucleophile from silver cyanide. So this silver cyanide react with alkyl halide through nitrogen atom which contains lone pair of electrons. This nitrogen atom attack on the alkyl halide by using lone pair and then remove the halide. So here the nitrogen atom attached to the carbon instead of attachment of the carbon. So we get RNC type compound, that is isocyanates. That is the reason why we get isocyanates by using silver cyanide, because it is a covalent compound. It don't liberate free cyanide which contains carbon negative charge. So there is no free nucleophile. The silver cyanide react with alkyl halide through nitrogen atom by using lone pair of electrons. That's why we get isocyanide as a major product. If you observe the reaction, it is reaction of alkyl halide with silver cyanide, then we get alkyl isocyanide. Here, if you take specific example, it is ethyl bromide reaction with silver cyanide, then we get ethyl isocyanide. Here, preparation of aryl cyanides or aryl isocyanide is generally somewhat difficult, because aryl halides are generally less reactive than the alkyl halide. It is difficult to replace halide nucleophile from aryl halides with cyano group or isocyanide group. It is due to the presence of partial double bond character in between the halogen atom and the carbon atom of the arene ring, due to the plus M effect of the halogen atom with arene ring. So they shows less reactivity when compared to alkyl halide. So it is not a suitable method to prepare cyanides and isocyanides by taking aryl halides. Okay, next preparation method of isocyanides. It is preparation of isocyanides from amines by using amines. If you treat here amines are three types. They are primary amines, secondary amines, tertiary amines. I developed 5 videos on amines: part 1, part 2, part 3, part 4, part 5. So you can watch them to know the basics of the amines. Okay, there are three types of primary, secondary, tertiary amines mainly. Here, in order to prepare isocyanates, we have to take only primary amines. Don't take secondary or tertiary amine. Only primary amines undergo reaction with chloroform in the presence of alkali solution to form corresponding isocyanates or carbylamines. Here, the primary amine it may be aliphatic or it may be aromatic, both. That is, aliphatic as well as aromatic primary amines undergo reaction with chloroform in the presence of alkali solution to form corresponding isocyanates or carbylamines or isonitriles. Okay, fine. Next, so the reaction, that is preparation of cyanides by using amides. In the last slide, I explained the preparation of cyanides by using amides, that is dehydration of amides by using dehydrating agents such as phosphorus pentoxide or acetic anhydride. We get corresponding cyanides. So if you observe the reaction, it is amide or CONH2. General formula of amide is or CONH2. If you treat amide with dehydrating agents such as phosphorus pentoxide P2O5, then we get ORCN, alkyl cyanide. If you take example, it is C6H5CONH2 is benzamide. Treatment of benzamide with phosphorus pentoxide, we get benzonitrile, or according to common system, it is phenyl cyanide. In the case of isocyanide preparation, in the last slide I explained about the preparation of isocyanide from aliphatic or as well as aromatic primary amines. That is, by treating primary amine, it may be aliphatic or aromatic, with chloroform in the presence of alkali solution, that is, it may be potassium hydroxide or sodium hydroxide, we get corresponding isocyanates. It may be alkyl isocyanide, or it may be aromatic isocyanide, aryl isocyanide, based on the reactant. If you take example, specific example, that is C6H5NH2, it is aromatic primary amine, that is, it is aniline. Treatment of aniline with chloroform, the presence of base, we get phenyl isocyanide. This is preparation of isocyanates by using primary amines. It may be aliphatic or may be aromatic. Next preparation method of cyanides, that is third one, is preparation of cyanides from aldoxymes. Here, what are aldoxymes? Generally, aldoxymes are, they are the derivatives of the aldehydes. That is, they are one type of derivatives which are obtained from the aldehydes. If you treat aldehydes with hydroxylamine, aldehyde general formula is ORCHO. It is one type of carbonyl compound. Carbonyl compounds are two types. One is aldehyde, second one is ketones. ORCHO is aldehyde general formula, ketone is RCOR. If you treat aldehydes with hydroxylamine, hydroxylamine is, the formula is NH2OH, then we get corresponding aldoxime, that is treatment of aldehyde with hydroxylamine, we get corresponding aldoxime. It is one type of ship bases. It is one type of ship base where the ship base contains C double bond N group. The compounds which have C double bond N group generally known as ship bases, that is C double bond N. This compound generally known as ship bases. Here aldoxime also contains this group, so it is also belong to ship base category. If you treat this aldoximes with some dehydrating agents such as phosphorus pentoxide or with anhydride, then we get corresponding cyanide. That is treatment of aldoximes with dehydrating agent, we get corresponding cyanides. If you take specific example, that is it is benzaldoxime. On treatment with dehydrating agent, we get benzonitrile or phenyl cyanide. If you treat ketones with hydroxylamine, we get corresponding ketoximes. Treatment of aldehydes with hydroxylamine produces aldoximes. Treatment of ketones with hydroxylamine produces ketoximes. Only aldoximes undergo dehydration in the presence of dehydrating agents to form corresponding cyanides. Okay, this is preparation of cyanides from aldoximes. Next, preparation of isocyanides from N-alkyl formamides. That is preparation of isocyanides from N-alkyl formamides. That is the N substituted formamides. That is by treating N-alkyl formamides with some dehydrating agents, we get corresponding isocyanides. Treating amides other than formamide, we get cyanides. But treating N-alkyl formamides, we get corresponding isocyanides. Okay, sorry. Here generally the dehydrating agents used are phosphorus oxychloride or benzene sulfonyl chloride. That is treatment of an alkyl formamide with phosphorus oxychloride POCl3 or benzene sulfonyl chloride, we get corresponding isocyanide. Benzene sulfonyl chloride generally is known as Hinsberg reagent, which is used to separate amines from their mixture. It is also discussed about the Hinsberg separation in amines video in my amide video class. Okay, leave it. Benzene sulfonyl chloride formula is C6H5SO2Cl. That is benzene sulfonyl chloride. By treating an alkyl formamide with phosphorus oxychloride, we get alkyl isocyanide. If you take example, formamide example, that is N-methyl formamide, in the presence of phosphorus oxychloride, we get methyl isocyanide, or it is also known as methyl carbylamine. Okay, this is about preparation methods of cyanides and isocyanide. Okay, fine. Next, physical properties of cyanides as well as isocyanide. The first one, if you observe the state of the cyanides and isocyanides, generally cyanides and isocyanides with smaller carbon atoms or with lesser carbon atoms exist as liquids at room temperature, but the higher one, that is the higher cyanides and isocyanides, exist as solids at room temperature, that is lower one are liquids, higher one or solids at room temperature. This is about physical state. If you observe the sorry, odor or smell, generally alkyl cyanides or generally they have faintly somewhat pleasant smell, but the case of isocyanides, they have unpleasant smell. They have unpleasant smell or foul smell. This is smell of the compounds. Next, if you observe the melting boiling points of the compounds, generally cyanides as well as isocyanides both have high melting and boiling points due to the presence of polar cyanide and isocyanide groups respectively. If you compare the melting and boiling points of cyanides and isocyanides, they have high MPBP values than that of the hydrocarbons and alkyl halides, which have same molecular weight. It is due to the more polar nature of cyanides and isocyanides. If you compare the melting and boiling points of the cyanides and isocyanides, the cyanides have more boiling points and melting points than that of the isocyanide. It is the more polar nature of the cyanides. That's why the cyanides have high dipole moments values. So they exhibit or shows high melting as well as boiling points than the isocyanide molecules. Okay, but the MPPP values of cyanides and isocyanides for generally they are less than that of the alcohols having same molecular weight. If you observe the solubility of cyanide and isocyanide molecules, the compounds with smaller carbon atom, that is lower one, generally soluble in water. That is only few compounds that is with lesser carbon atom generally dissolves in water. It is due to the capability to form hydrogen bonding with water molecule. But higher cyanides and isocyanides don't dissolve in water, but they dissolve in organic solvents such as carbon tetrachloride, benzene, whatever it may be. That is solubility of higher one is high in organic solvents. The smaller one, that is lower, with small or few carbons, slightly dissolves in water. Mainly their solubility is in organic solvents. Okay, due to this partial polarity nature as well as capability to form hydrogen bond, they also dissolve in water. But the molecules which have smaller number of carbon atom or lower molecular weight. Okay, fine. This is all about physical properties of the compounds. Next, chemical properties of cyanides as well as isocyanides. So observe the chemical properties of the cyanides. Cyanides chemical properties. The first one, the first chemical reaction is hydrolysis. If you hydrolyze the cyanide compounds in the presence of acid or base medium, then we get corresponding carboxylic acid as a major product and we get ammonia as a byproduct. That is, hydrolysis of cyanides in the presence of acid or base media produces carboxylic acid as a major product, ammonia as a byproduct. You observe the reaction here. Cyanide, alkyl cyanide or CN hydrolysis in the presence of acid or base forms carboxylic acid or COOH. That is, it is the major compound and the byproduct is ammonia. If you take example, specific example, phenyl cyanide on hydrolysis produces benzoic acid along with liberation of ammonia gas. But in the case of isocyanides, that is hydrolysis of isocyanide, if you observe the hydrolysis of isocyanides in the same condition, that is hydrolysis of isocyanides in acid media or base media, we get primary amines as a major product and formic acid as a byproduct. That is hydrolysis of isocyanide or NC. In the presence of acid or base media, we get primary amine along with the formic acid. So in the case of cyanides hydrolysis, we get carboxylic acid, ammonia. In the case of isocyanide, we get primary amine, formic acid. So based on this difference in hydrolysis process, we can differentiate the cyanide and isocyanide group present in a given compound. Okay, hydrolysis is helpful to predict whether the compound contain cyanide functional group or isocyanide functional group. Okay, fine. Next chemical property. Reaction of cyanides with Grignard reagents. Grignard reagents. The general formula of Grignard reagent is RMGX. That is generally they produced treating aryl or alkyl halides with magnesium metal in the presence of dry ether. Then we get corresponding Grignard reagents or MgX. Treating alkyl cyanides or cyanides with Grignard reagent, we get an addition product due to the nucleophilic substitution of alkyl or aryl nucleophile coming from Grignard reagent on cyanide group. That is reaction of cyanide with Grignard reagent, we get an addition product. This addition product undergo hydrolyze to form an imine intermediate. This imine intermediate, the next step, undergo hydrolyze or hydrolysis to form corresponding ketone. That is reaction of cyanides with Grignard reagent followed by hydrolysis produces ketones. Here the ketones further may undergo reaction with one more Grignard reagent and followed by hydrolysis produces tertiary alcohol. So reaction of cyanide with Grignard reagent does not stop at the ketone level. Instead, the reaction carried out up to formation of tertiary alcohol. Okay, there is no reaction of Grignard reagent with isocyanides. If you observe the reaction, that is Grignard reagent reaction with cyanides, here the cyanide, that is RCN, undergo reaction with Grignard reagent or MgX. Here Grignard reagents are best source for nucleophile, hydrocarbon nucleophile. This carbon nucleophile or minus undergo attack on the cyanide carbon, then the one bond shifted to nitrogen atom, then we get an addition product. This addition product on hydrolysis produces an imine intermediate. This imine intermediate on hydrolysis produces ketone. This ketone further react with one more Grignard reagent and produces an addition product. That addition product also undergo hydrolysis to form tertiary alcohol as a final product. Okay, fine. Next, reaction of isocyanides, that is reduction of isocyanides. Here the isocyanides undergo reduction in the presence of different reducing agents or they may undergo reduction in the presence of catalytic hydrogenation to form corresponding secondary amines. That is reduction of isocyanates in the presence of reducing agent or reduction of isocyanate with hydrogen gas in the presence of metal, that is catalytic hydrogenation, generally produces corresponding secondary amines, that is RCN. Reduction with reducing agents such as lithium aluminum hydride, or it may undergo catalytic hydrogenation. Catalytic hydrogenation means hydrogenation in the presence of metal, that is it may be nickel with hydrogen gas. Then we get corresponding secondary amine. For example, methyl isocyanide undergo reduction to form secondary amine, that is NN dimethyl amine. Okay, fine. Next one is reduction of cyanides. Cyanides also undergo reduction to form corresponding primary amine in the presence of reducing agent, or they may also undergo catalytic hydrogenation to form corresponding primary amines, that is RCN. Alkyl cyanides undergo reduction with lithium aluminum hydride or undergo catalytic hydrogenation to form corresponding primary amine. For example, methyl cyanide on reduction with lithium aluminum hydride produces ethyl amine, that is reduction of cyanides produces primary amines, while reduction of secondary amines, reduction of isocyanates produces secondary amines. So based on this reduction property also, we can differentiate the given compound whether it is cyanide or isocyanide. That is by using hydrolysis as well as reduction property, we can differentiate cyanide and isocyanide compounds. On reduction, cyanides generally produces primary amines, while isocyanates produces secondary amines. Okay, fine. Next, oxidation of cyanides. Observe the oxidation reaction. Only cyanide molecules, only isocyanide molecules undergo oxidation to form corresponding isocyanates. Here the alkyl isocyanates undergo oxidation with some mild oxidizing agents such as mercuric oxide, mild oxidizing agents to form corresponding isocyanates. That is isocyanates general formula is or CNO, alkyl isocyanates formula is or NCO. Isocyanate is or NC. If you add one oxygen, then we get isocyanate, that is or NCO. That is oxidation of isocyanates with mild oxidizing agents, we get corresponding isocyanates. If you observe the reaction here, alkyl cyanide undergo oxidation with mercuric oxide HgO to form corresponding alkyl isocyanate. If you take specific example, methyl isocyanide undergo oxidation with mercuric oxide to form corresponding methyl isocyanate. If you observe the characteristic of isocyanates, here the isocyanates are very poisonous compound as cyanates. Isocyanates are generally they are very poisonous compounds. So due to this poisonous nature of isocyanates, generally isocyanate used in the preparation of pesticide compounds, that is in industry level, cyanates generally used to prepare pesticides. For example, here methyl isocyanate. Methyl isocyanate, it is commonly known as MIC. MIC. You may also aware of this compound, that is MIC compound, that is methyl isocyanate. Here the methyl isocyanate is responsible for Bhopal tragedy. It is the responsible for Bhopal gas tragedy or Bhopal gas industrial disaster, which takes place in 1984 December 3rd. Due to the leakage of this methyl isocyanate gas, from a pesticide industry, that is the industry name is Union Carbide Indian Limited, Union Carbide Industry. From this Union Carbide Industry located in Bhopal in 1984, methyl isocyanate gas, MIC gas, is leaked. This due to leakage of this poisonous gas, these people surrounding the area went into unconscious, or some may undergo death spotly. Nearly 5 lakhs plus people affected due to this MIC gas leakage from Union Carbide pesticide industry. This is one of the world's worst industrial disaster. Okay, fine. Next. Thank you very much for your patience. Thank you one and all for watching this video. Thank you. Bye.